Welcome everyone. Thanks for watching. Welcome to Mr. Metric. The building that we have in front of us today is this exhibition hall, which is part of the XiangCheng urban planning. So this building is located in China. It's located in Shaosu. I hope I pronounce it in the right way. And it's made by Lacime architects. And so the initial shape of the building is a box, and there's a sort of like organic curtain that's wrapped around this box. And especially that's the one that we're focusing on today in today's video. So if we go through the parameters, we have a box dimension. This applies to the x and the y of the box. We have the box height, which is straightforward. It's the height of the building. This is the amount of panels per orientation. So actually you see, so let's bring this, I think 100 is a nice number for this size and shape. On the south facade we have two curvatures or two graphs. With this one we can control like where they take place. I like this one actually, 0.6. So the initial graph or the curve is created by this graph mapper. So this one is applied on every facade graph and also on both of them on the south side. And this is actually the first direct input that you can have on the curtain graph. Here per orientation you can actually like amplify it, making it bigger, smaller, higher. Besides that, we have the height amplifier. So here you can make it higher if you please so. Like it starts basically at 0.50. You can go all the way up like this. Really like a sort of curtain in that sense. We also have like the height rescaling. This makes this, if you see it from the side, you can see it's a sort of like, well, it's almost like a parable. With this one we can make an hyperbole out of it. Maybe we can put a lot of nuance on how we want the graph to operate. And we have the curvature factor. So putting this guy all the way to 0, you get like a straight line here. And we can create some more organic wave in there. And those are the parameters that we have today. So it's all further ado, enjoy the video. Let's dive in. Let's bring all the parameters towards the canvas. Let's also activate bifocals. This allows us to see all the names of the components that we're using. So these are all the parameters that we need for the script. But instead of going through them one by one, I will start talking about them as soon as they become relevant for what we're about to gonna do. So we're gonna start with the top two ones, the box dimension and the box height. The box dimension is for the x and the y. And the box height is for the z dimension. Let's bring these guys here. We're gonna make a box domain. Yes, a box domain. Yeah, like I said, this one applies for the x and for the y, and this one for the box height. The only thing is that I'm not really satisfied with at the moment is that the dimension currently is 25. It makes a domain from 0 to 25, where I want 0 to be the middle of the domain and not the beginning. So we're going to use a thing which is called center domain. It is from the Wombat plugin. And here you see, right? So now our point is exactly nice in the middle. This is a little bit the first step. Let's create a variable that says like box. Because basically this is the base shape of the building. It is the shape that's gonna host the facade that we're gonna dive into now. And like it's gonna be the host where we're gonna make this nice curved facade, both in a, in a vertical and also in a horizontal dimension. And well, here is actually what we're gonna create, and also the box main shape which we just made. So let's go back to the script. Let's bring this guy in. Let's give everything a bit more space. Yes, let's start from this guy. Okay, what we're gonna do now is we're gonna deconstruct this B-wrap. Again, we're using the Wombat plugin because it already distributes it between the top curve the bottom curve and all the side curves, which is nice. It's not something that we have to do afterwards computationally as soon as you work with the deconstruct B-rep. The deconstruct B-rep is this guy, by the way, but this one just gives you all the faces, all the edges, or all the vertices, instead of them dividing them by top, bottom, and side. Let's work with the bottom first. Let's offset this guy. We offset the curve. Let's use here a fixed value of 0.3. You can make this into a parameter, of course, if you want, but for me, I'm fine with doing it to 0.3. One thing to note is that we want here to be smooth. We want here to have like a round curve. So we can go to smooth. So you see here that it is creating like a round curve. You can either do it by right-clicking. What you can also do is that you see smooth is an index of 3. So you give it an index of 3. Both ways are possible and none of them is right or wrong. What we want to do now is that we want to explode this curve. Exploding this curve, let's also hide the box here. Exploding the curves will give us like 8 curves, 4 straight ones and 4 round ones. If we use a dispatch here, which is dispatching this list into 2 different lists with a standard pattern of true-false, meaning that all the 8 items, one goes into the A, next one goes into the B, and that pattern continues until every item is used in the list. This creates a nice list of the straight curves and also a nice list of the short curves. Perfect. Let's call this one long. Yeah, and let's call this one short. Perfect. Yeah. What we want to do now, what you also see here in this image, is that some facades have just one big curve, graphed curve. Some facades have two big, two graphed curves. Right, so I want both of them to be part of my algorithm that I'm creating. So what I'm going to do is that the south facade, I'm going to divide that with the parameter, which is going to be parametric with a slider. And it creates like 2 graphed curves. So that is the next step that we're going to do. But before we dive into that, we're going to talk about the next parameter. The next parameter is frames. So let's put this all a little bit down. Let's bring frames up. The next is going to be frames. Yeah, because with this one we can decide how many frames we're going to have per facade orientation. So we're going to divide the long one. Yeah, we're going to do an evaluate curve. Yeah, bring this guy in. We need to reparameterize this one. What it means that whatever the length of this curve is, we just bring it back to 0 is the beginning and 1 is the end. We have our frames over here. It is 100. So we're going to create a range. And this range, the domain goes from 0 to 1, right? That perfectly aligns with the reparameterized curve that we're doing here. And the amount of steps is 100. Do note that if this guy is 100, it gives you 101 points out of it, because it has a beginning and a start. Now, hence why it is 101. And we simply bring this guy in there. Oh yeah, 2 things what's not going wrong properly at the moment. We need to graph this because we want to have this. It's caps lock. We want all those 101 numbers to be applicable to every individual curve. So we need to graph them. And as soon as we do that, you see that every curve nicely gets divided by 101 points. Okay, so what we're going to do now is that the south curve, which is this one, I suppose, we want it to break somewhere here, right? That we can create a curve over here and that we can create a curve over here. Since what we currently have is 4 data branches, let's simplify this. Every orientation has its own branch and it has 101 points. So we need to create a similar data set, meaning with 4 data branches. I like to use the entwine component for that. There's only one facade that we want to divide by a certain number, and that's the south one. So only that one we need to manipulate. And for that, we need this parameter. We split parameter south. This value simply goes from 0, no, not even, no, 0.3 up until 0.7. Let's bring this guy in. And what we need to do now is we need to list length, because here we have 101 values. We know that, but here now we have an actual value that comes out of it, that it contains 101 values. And we're going to multiply these guys with each other. And this gives us the number of 17.7. Well, since we're gonna, since we need an index, we need the whole number. So we need an integer. Right, so just put integer behind it, and it automatically rounds it to the closest one possible, 71 in this case. So what we're gonna do is we're just gonna put this guy into 0, 1. Right, so here we have like 4 data branches. Here now we also have like 4 data branches, and only one of them contains a number, which is, no, actually they all contain a number, but all of them 0, except for data branch 1, which gets the number of 71. Actually, to show you that, 0, 71, 0, 0. Yeah. Okay, let's do split list. Yes, because we want to split this list. The index that we want to split it at is, well, 3 lists we don't want to split, so 0 is not going to split anything. But in the first one, it's going to split it at 71. So what do we get out of this? So here you see that you get 4 branches, in all of them 0 items, only one contains 71 items. The other part of the list is that you got the full 101 numbers, and here you got the 30 numbers. Right, so also if you show that, here you have like your 70 numbers, and also if you play around with the split parameter, you simply change the amount of numbers that are part of that, and also simply the length, the width of the graphed curve that we're making. But one thing, so we're gonna simplify this, and we're gonna simplify this one. What you see happening here is that if you're gonna merge these curves, these points, actually let's simply do that, it's gonna bring it back into like 4 data branches. So that's the opposite of what we want. Because now, since we merged them, they will be brought back together. So we need to manipulate the naming convention of the data branch. So we can do that with a pattern. So these ones I want to keep a, but put a 1 behind it. So what's doing it here? So it creates a 1 behind it. Here I'm doing something similar, but instead of a 1, I want a 0 behind it. And you see what's happening here, right? Because you see, if I merge them now, they give me 8 lists, right? Because this is 0, 0, and this is 0, 1. So hence they don't merge, because they all have their unique identifier for the data branch. We do now have like 3 branches with 0 values in there. I want to get rid of them. So we're gonna clean 3 and put this guy to invert. So that means remove empty. And now I have like 5 branches, 3 of them containing the full 101 points. And the south facade is now divided by 50 and 51, depending on the value of the parameter. Perfect. So let's call this bottom points. Yeah. Yeah, let's keep the short a bit below. Since we did all this at the bottom curve, so this is our box, we did all this at the bottom curve, right? This guy says bottom. The nice thing is now that we can completely copy this whole thing here. Just put the top curve there. Yeah, and this, yeah, well, now. These are now our top points. So here we have our bottom points, here we have our top points. We can actually hide everything. The only thing that I still want, yeah, so we have short 1 and short 2 basically, right? Because this is also short. These are just the small curves. We're gonna manipulate them later, so that's why I could put them at the bottom at the moment. We have our top points, we have our bottom points. I just want one more thing, and what I want is the normal. So what comes out of here is called the tangent. So if we make a line with this tangent, it goes to the side as you see them, but I don't want that. I want this line that we're creating, which is going to be used as a vector later. I want it to go outside of the facade. Well, there's a nice little component that can do that. So we put the t into the a. So we're gonna make a cross product, and we put a z vector in there. A vector, lines, curves, in the end they're all the same. And what happens now is that I create this vector that goes outside of it. With this vector, so we also have like so many vectors, so we're gonna do the same game for this guy. Because the way how the bottom and top points are currently distributed among the branches, we want to do the same with the vector. So we're doing this as well. This one gives red because this is a point container. Let's just make this a vector container. And also call this guy vector. Yes, this one. Yeah. Okay, we're done now with the first step. Okay, the next step is what we're gonna do is that the bottom points, gonna distribute them to like a new point. We're basically gonna create the curved graphs at this point, right? So what we're gonna do, so first let's get a list length of how many points are in each branch. With that, we're gonna make a range, a similar component that we used earlier on in the script. Since we want to keep the same amount of points, right? So here we have, let's put a different one. So here we have 100 points and 50 points. The thing is, it creates an additional one, right? So it has a beginning and an end point. To deal with that, I'm going to put an x minus 1, and you see that the amount of points here are equal now with the amount of points that go in the range component. The next thing that we're going to bring in is a graph mapper. Here we're going to create a graph mapper, and here actually we're going to create the curve, the graph that we're going to apply to the curve later. So for this one, we apply a Gaussian. Yeah, let's keep this point in the middle. With this one, you can change the vertical distribution. This one, the horizontal one. We're gonna remap these numbers, right? Because what happens, these numbers always goes from 0 to 1. And we want to manipulate them. We can do that with the remap numbers. And so these are your values that you want to remap. This is the source. So with bounds we get like the minimum and the maximum point. And then we can create a new target that we would like. So we can make a construct domain. And we can put that into this guy. Right, so okay, we have here our bottom points. Let's also keep calling them bottom. Yeah. Let's bring them in. These bottom points, we're gonna move them somewhere else. So let's put the bottom points there. Here we also have a vector. We also need to use our vector because we're gonna deconstruct this vector. We're gonna construct the vector. Actually, we can just go to this guy. With this one, we can create the vector. Yeah, in order to continue, just put a little bit back. Let's give everything a little more breathing space. These remap values, they can go into the Z dimension. And so we have created a vector here. And with the amplitude component, we can give a certain length that we desire for the vector, because a vector standard has a value of 1. And we can change that at this point. So for now, so the amplitude, this is where we can change the value, but keep this at 1. And let's bring this into the move component. What you see is that the height distribution is already in here. You see that the value of 1 shouldn't be the case because it's equal everywhere. So if we would use these remap numbers, then we're gonna create this nice distribution that you're seeing here. Let's get rid of the vectors. Maybe let's also get rid of these points. Yeah. You actually see what's happening. So like all the values are now 1, so it creates an equal graph. For that, we have the next parameter in place. So this domain that we created, if you don't put the value, it automatically applies a 0 and a 1. So this is where our next set of parameters come into place, and that's this. So we have 5 different graphs, one here, 2 in the south, and 1 in the east, that is then. For each one of them, we can apply a certain amplitude, and so they can all behave in a different way. these are already mapped, as in like each value is in their own branch. We can bring this in, and we can actually apply these numbers. And now we can actually, with this one, we can actually control the graph, like how should it behave. Also in the height, you can play around with it. Per individual graph, we can play around with changing these vectors. You don't see anything happening at the moment, but individually, you can change them. There's only one more change that I want to do. So this amplitude over here, there's only one more thing I want to change, is that this value of z, I want to put like an amplifier to that as well. Seeing a multiplication is almost a different synonym of amplifying something. So for now, let's keep the value of 1. So if we do that, it's not going to change anything. But as soon as we're going to put a different value here, so let's change this value to a 2, you see that it changes the height. And so this gives us a little bit more freedom to create the graphs that we like and we envision in that sense. And for that, I have another parameter, and that is the height amplifier. Let's turn this up to 1.72, 27. Let's replace this guy. Okay, so we have a fully working graph. What we can already do from this point onwards, we can create a line that goes from the bottom. We have our top points here. Let's just simply call top. Let's bring this in. Maybe keep everything in line. So you can see that it's already working. It still looks a bit funny, to be honest. So there are some things that I don't really like. One thing that I don't like is that you see this going up. I would like to see that the other way around, that it goes more from into like a parabole into like a hyperbole. And another thing that we see is that this line is straight here at the moment, and that's also not something that we desire. So those are two things that we're going to deal with now. So let's get back to this. Let's get back to here. And now we go to the third step. Okay, what we're going to tackle now is that instead of this hyperbole, we want to make it a parabole. So we need to do some mathematical equations here. So the first thing that we're going to do is we bring this curve down. The thing is, this line has a domain from 0 to 1. We want to make the domain of this line similar as the length of the line. So we're going to get the length component. We're going to take the component which is called curve domain, where we can actually apply like a new domain to the curve. And the domain that we want to do should be the length of this one. Well, so since we want to gather some new points, again, we're going to work with evaluate curve. And so in order to get that hyperbole, so the inverse of the parabole, we will get this data over here. Let's get the bounds, which is the minimum and the maximum value. Let's deconstruct this. Should be DD. Yeah, deconstruct domain. So this is already grafted. Yeah, we're gonna merge them. So this is the start and this is the end of the domain. And we get the average out of it, the average number. Yeah, so where the numbers here go from 0 to 3, the start is then 0, the end is 3. If we get the average out of it, it's 1.5. What we're then going to do is we minus this with the remapped numbers as such. We then divide these with each other. Then we get the value that can be only 1 as maximum, and the minimum is a 0, but also minus. It goes to minus 1, of course, because this is the average and you subtract it from the full numbers. Then we're going to round these numbers. No, we're going to square them. My bad. We're going to square them. And then, because also the negative values, they become positive again as soon as we use square. we're simply gonna put a subtraction here, a 1. And now we're gonna get values which it should start with 0, and it should be maximum 1 somewhere in the middle. Let's give a check to that. Let's put these numbers in here, and you see that we get our parable. Of course, we want to have some control over the behavior of this parable. So let's put the subtraction in here. Let's get our height amplifier. Are we already using the height amplifier? Yeah. Then it is the height rescaling. Let's bring in the height rescaler. And now we do the multiplication again. So with this height rescaler, we can choose how it should behave. I like a value of, let's say, 0.65. This looks nice. Yeah. Okay, so now we have our new bottom point. Let's also call it as such. New bottom point. Correct. I do like to see the curves, by the way. Let's keep this in. Now we can go to the next step. What we're going to tackle now is that we want to get rid of this straight line here. So what are we going to do? We're going to create a new line, also with our new bottom point and our top point. Let's bring the top point in. Keep your canvas organized, please. You will do me a favor, but you will also do yourself a favor. Okay, let's get the middle point here. You do know by now that if you reparameterize this and give it a value of 0.5, it basically says like, give me 50% of the curve, which is half. At this point, we're gonna move this. We're gonna move this point closer towards the facade. So we have our vector somewhere here. Yeah, we have our vector. Let's bring the vector in. Let's bring the vector towards here. Yeah. We need to inverse our vector, right? Because the vector was going outside of the facade, while we want this point here to move back towards the facade. So we're gonna put a reverse in here. And if we put this now here, you see that the point from here goes inside. Yeah. This is not what we want yet, right? Because we don't want it to be equally distributed, how far it should go towards the facade. So we're going to put a brep closest point of this point here, right? So point goes into point. And we want the brep that we're going to use is the box that we created. And with the box is just our main box, the one that hosts the facade that we're currently creating. Since the offset of the current facade that we applied in the beginning is 0.3, the value will start at 0.3 and will only go up no matter the point is further away from the facade. So all these values, we're going to minus them with 0.3. Because there we want the point to be stopped. And then you see that the first value goes to 0. Yeah. So this one over here, we can change the value of a vector. We also know that by now we can do that with the amplitude. Basically, this is our amplitude, which we can now give towards the point here. And what you also see happening now, I'll hide this. You see that it goes like fully towards the facade, and that is also actually not something that we want. So again, we're gonna manipulate this number as well. And we have a parameter for that. That's our final parameter actually. It's the curvature vector. Let's bring this guy in and let's apply it. And let's apply it back to here. So what we see, if we play around with this vector here, if it's 0, it's the original point. If it is 1, it is all the way to the facade or with the 0.3 offset. But somewhere in the middle, well, that creates like a nice balance. What we're now going to do is we're going to recreate the facade curve. But now we're going to use a NURBS curve. And put the degree to 2. It's automatically at 3, but to put it to 2. We need our new bottom curve. Where is, our new bottom point. This is our middle point, right? The one that we just created. This is the middle point. Yeah, so this is our middle point. And we need our top point. Our top point we haven't manipulated so far. Which is simply just always the top, right? Let's give it one more towards here. Yeah. Let's put it in the right order. Middle, top, top. We need to graph them everywhere, because now I get like 5 branches with those 101 and 50 points in there. But at every point, I want to create a frame, right? So every point gets its own data branch. We do that for all 3 points. So if we merge them, we do have to simplify them. So the amount of branches that we're going to get is the amount of frames we have, 404, which seems right. And it's distributed among like 5 different facades, right? So north, east, west, and south 1 and south 2. So this is perfect. Let's bring them in. And we've created our new curves with our new points. So let's hide all this. Where we have like full control over the bottom part here. With the curvature factor, we can actually choose the curvature, like make it a bit more elegant, I would say. Let's just put this at 0.55. The height amplifier, it's actually this guy. The amplifier for the graph, and we can even control the graph itself. So we have like a lot of points to play around with the curve, or how we want it to behave. Time for the next step. Okay, we're almost there. For now, these are the newly created curves. We're gonna offset this curve. We're gonna offset with a value of 0.2. So this is gonna be the width of my facade panel. What's happening now? It's doing some weird things here and there. So one thing that I like to do is we need to make a new plane. So with this vector, let's bring this vector in. Let's create a plane. Construct plane. Construct plane, yeah. This is what we're gonna create. The vector is the X, and then the Z direction is the Y. And here you see that the red one should go outwards, which is good. So let's create this plane. Call it plane. Let's bring it in. One thing to mention here is we've grafted all our frames, right? So the data branches, we had like 404 curves. And here it's still the old data structure. So let's also graph this. And then bring it towards the plane. Yeah, and what you will see now, oh, this value is a bit hidden now. So this is inner curve. And this is outer curve. Let's also hide the plane. We don't need it anymore. So inner curve, is that correct? And this is outer curve. Perfect. Okay. Also, just to show you how they look now, because we can create our panelization. Let's simplify against these. Oh, this is grafted and kind of simplified. If we would put a simple loft operation here, we have all our panels. We're not gonna do a loft operation. It's quite a heavy operation. We're gonna mesh them, but that will happen after this. These curves, we want to rebuild these curves again. Because again, the domain of these curves are 0 to 1. Well, we want the domain of this curve to be the length of this curve, right? So we're gonna do that separate. So not the list length, no, but the actual length. Yeah, this goes into the y. The degree here in this case is 10, because later I want to make 10 frames. I will dive into that a bit later. And yeah, let's just see this. Let's just copy this. Yeah. And now let's bring them together. And we're gonna call these panel lines 1. Voila. So the next thing that we're gonna do, we've dealt with like the long lines over here. We still have our 2 short curves over here. In the meantime, let's also check how we're doing with the computational time. So at the moment it takes 84 milliseconds to run the whole script. So I think we're doing really good at this point. In the end, it's just points and curves that we're busy with. So let's keep that efficiency going. So for the short 2 curves, we have a component which is the frames, which dictates how many points they're gonna be and how many frames per facade. So we want to use a bit of that logic, right? So let's use these points. These are just the points, the bottom points. Let's bring them in here. Let's call them points. And let's send them towards here. Because what I want to know with these points is, let's just take the first 2. I want to actually know what this distance is, because this distance I'm going to use in order to define how many points we're going to create over here. So there's a component which is distance. And this will give me 4 values, since, well, it's everywhere the same. Let's use a create set. A create set is, it just shows you all the unique values. And there's just one here, it's a 0.25, right? Okay, so now tell me what is the length of this short curve over here. Let's just put them here on top. The length is 0.49, 0.5 almost. So if we divide, let's also create a set here, by the way. They're all the same numbers again. So let's divide this by this, and this should give me around 2. Well, really close to. Let's make an integer out of it. Yeah, so this will give me the value of 2. Correct, yeah. So that basically means that this distance fits 2 times in here. So basically I want to create like 3 points here, or 4 points. We don't want to use the first point and also not the end point, because these frames are already created. So let's do a range, because range is always the value between 0 and 1. The amount of points here is 2 points. Yeah, and since a range starts with the beginning end, it also creates the middle point. So this will be interesting, because if we evaluate curve, you know that component by now. Is it extend curve? Yeah, sorry. We want to have evaluate curve, correct? Reparameterize this, and now we get 3 points. Right now we can just use the first one. So let's do a small trick. Let's just do x plus 1, excuse me. And now we get 3 points, right? Oh wait, we need to graft. Never forget to graft your lines. Yeah, so now we get 4 points here. And that's actually exactly what we want, because now we're gonna curl the first curve and the last curve. If you use a -1, it's always gonna be the last curve, because those curves we don't want to create. And you need to multi-line data this. So now we just have these 2 points here. Again, we need to graph them, because each of these points should be its own frame in the end. And actually, this is what we also need to do for this curve. Let's hide this. Yeah. Let's bring this here. Yeah. And we have our 2 points. So we can make a line out of this. Perfect. The only thing that we need to do is we also need to bring them outwards, right? Because we just have these 2 curves over here. You know by now that we can use the tangent. We need to cross product. This is also an exercise we've already done, so you must be familiar now with it. We moved this guy, and what did we decide before? We moved it with 0.2. Yeah. So again, we're gonna get this vector, put an amplitude of 0.2, and then give to this. Something is not right here. So these are, let's see. So we've created this, and this is, oh yeah, wait. Yeah. So first we need to do this. Then we need to graph as well. And now we can do this. And voila, we have our inside curves and we have our outside curves. So now we're gonna merge them in a similar sentence as they did over here. So we have our inner curve, our outer curve. Maybe let's actually just copy these two things. Bring them here as well. So these are our inner curves. These are our outer curves. Then I'm actually also just gonna copy this whole bunch here. Put it here as well. We're gonna rebuild the curves just like we did previously. This can go in here. And these are now panel lines 2. Yes. Yeah. So actually, let's hide everything. We have our panel lines 2. Let's bring it here. We have our panel lines 1. Let's both see them. And voila, we have our frame. And whatever is happening, the amount of frames that we apply, it also has an effect of how many curves that will be made on the outer corner, if you see so. We can make it more computational. So what we also see in the actual building, the actual facade panels, you see basically that you have like 10 different surfaces on such a facade panel, and 2 of them are culled. So that means that 8 of those facade panels, they're there, and 2 of them are culled. We're gonna copy that exact behavior. So let's zoom in what we're talking about here. So when we want to do that, let's first like stack these. Right, so let's stack these. Stack trees, just stack them, perfect. Yeah, so we have 815 panels at the moment. Is that going well? I do see one small mistake here. The panel lines 1, they're not properly branched. So we need to go back a little bit here. The only thing that we need to change here is that we need to simplify these 2 values. And then everything is branched. Every branch has 2 items. So we go back to here and we see now that how many facade panels do we have? 412. Okay. So I see that I have like 2 items in each branch. That's perfect because we're gonna create a third curve. And that should be in between the 2 curves. So we have an A, we have a B, and now it creates an inner curve, as you see over there. So these are the outer curves now. We created this inner curve. So we're gonna rearrange the order a bit. So this is my first curve. This is the beginning curve, the inner curve, let's say. This is the middle curve. And this is the end curve. Let's give it a bit more clear. Okay, cut. So what we're gonna do now is we're gonna call a component which is called MeshLoft. Yeah. You see that it makes a mesh. Put Ctrl M so you can actually see the mesh. With Ctrl M you can preview or not preview the mesh. Let's hide all this. We see here that this is a value of 10 and this should be 5, if I'm correct. Because we have like 1, 2, 3, 4, 5, 6. Yeah, I think we have like 7 panels everywhere. Like we said, a few panels we can hide. Also, by the way, we're using a mesh operation because in terms of computational time, we're at 100 milliseconds, which is absolutely nothing for a Grasshopper script. By my head, I think it is 1 and 3 that we can curl. Curl means that we're gonna get something away. And it's not really doing that. Okay, so it's one big mesh. We need to explode the mesh. Mesh explodes. Yeah, mesh explodes. Which gives us then 10, as you see over here. Every data branch has 10 surfaces. So that means those 10 surfaces that we just accounted for. At the moment that we do this, you see actually what is happening. So it takes away the inner facade, the inner two. Yeah, actually, we have the script already. It's there. So we're actually mimicking exactly what is happening here. What we can do now is actually we can give thicknesses to the facade panelization. Let's just keep this here just to see what's happening with the computational time. Cut. Okay, so every panel should go in its own tree again. So here we had 10 items per tree, per branch. Here we had 8 items because we curled 2 with index 1 and 3. Now we bring each of them into their own branch again. Now we're gonna do offset mesh. And I want to give it a thickness of 10 centimeter. So what I'm gonna do there is, yeah, I'm gonna create 0.5, I should say. And also the negative value of that. So let's also bring the negative value in, because that gives us 2 values. Yeah, and let's apply them. Yeah, and you see, so it nicely gives us that thickness, right? I mean, you can always change this to 0.03 if you like it more sleek, but let's do, yeah, maybe 0.4. Yeah, let's do that. And let's make a custom preview out of this guy. This is looking very good, I have to say. I don't like the color. Let's just go to a white color. It's starting to look pretty sleek already, huh? Yeah. Cut. You do see that this takes relatively a lot of time, 184. What we can do is, what is always good to do with the mesh, there is a nice component which is called mesh join. Just join the whole mesh into one. Hey, it will create a lot of mesh faces, but also if you put this in here, you see like how much faster it actually is. And so let's all hide all this. Let's just show this one. And now we are still at 175 milliseconds, which is absolutely nothing. Let's also bring our box in. And let's also put this in here. And you actually see how nice our facade is, right? It's really good. Let's hide this. So we're at 175 milliseconds. We can put like less frames in. We can go to as low as possible if we want. Just make it higher. We can choose where we have like the split south parameter, right? We can put it a bit there. We can put it a bit there. We can change it, right? So I think this is west. Wow, good in one go. We can make it very extreme. We can play a bit around with the height. How should it behave? The height rescaler, right? Should it really be a hyperbole or like a parabole? How should the curvature behave? And with that, we actually have recreated this facade over here. Yeah. Maybe just see it without the box. Then it's a bit more visible what we've created. Okay, thank you for watching. Up to the next one.